Okay, so let's say that this is a red blood cell. So what makes up the outer layer of this red blood cell? Well, since it's a cell, it has a cell membrane, and that's made up of lipids. But embedded in those lipids, there's all kinds of proteins and molecules, some of which I'm drawing here, that have all kinds of different functions. But there are two of them that are sort of more important than the others, at least for this topic that we're going to talk about, and those are the A molecule and the B molecule. So I think you'll be pretty happy with those names, not too hard to remember. And I'm actually calling them molecules and not proteins because they're actually not proteins. They are actually something called glycolipids, which I actually didn't realize at first. Glycolipids. Glyco meaning a sugar group, lipid meaning like a fat group, so it's like some kind of mix of a sugar and fat. You can look it up if you're interested. But what's interesting is that not all people have both of these molecules, these glycolipids, on their red blood cells. Some people do have both, but some have only one. So for example, some people might have only the A. Or, as you can imagine, some people would have only the B. And some people, can you figure out the last possibility? Some people have neither A nor B. And of course, all these people have all kinds of other proteins and molecules embedded in their red blood cells. Now, the reason why we care about this and why I'm talking about these A's and these B's is that in medicine, we often have to give blood transfusions. So let's say you got in a car accident and you lost a lot of blood. You're rushed to the hospital, and if you've lost enough blood, they'll give you a transfusion of blood. Transfusion just means they'll put a needle in your vein and pump blood into your veins. But it turns out that you can't just give any blood to anyone, and it has to do with these A and B groups. And so, for example, it turns out, and we'll explain this, but for example, it turns out that if you are the kind of person who has this kind of blood that only has A's on your blood cells, then it turns out that you can't get a blood transfusion from someone who has this kind of blood, A's and B's. And so let's learn why. So if you remember from the immune system, there's something called an antibody, and we usually draw it in this shape here. So if you remember from the immune system, your body has something called antibodies, and it uses these antibodies to fight things that it doesn't want in the body. So for example, if you have a bacterium, I'm drawing one here, you'll have an antibody that'll bind to that bacterium, and the purpose of that is that now your body knows that it should destroy this bacterium. So this antibody is kind of like a tag that marks this guy for destruction. But your body is very careful not to make antibodies against itself, which is obvious, right? Because if your body made antibodies against itself, then it would start to attack itself. So for that reason, someone who has this kind of blood, which means that all of their red blood cells have A's and B's on them, that person would not want to make antibodies against the A and the B molecule. Because if they did, then their body would attack all of their red blood cells. So these people don't have these antibodies. But let's say if you have this kind of blood, then you might not make an antibody against the A molecule, but you can make it against the B molecule because the B is not in your body. And so there's no risk that your body is going to attack itself by making an antibody against the B molecule. So these guys don't have the A antibody, but they do have the B antibody. These guys, on the other hand, they can have the A antibody, but they don't want the B antibody because then they would attack themselves. Whereas this final guy, can you guess what he has? So he can actually have both A and B antibodies. And he actually will have both, because that's the way your immune system works. It makes antibodies against pretty much anything that is not you, that is not yourself. And A and B molecules are not part of this guy. He has none of them, so he'll make antibodies against them. So now let me ask you, what would happen if this guy, someone with just A blood, type A blood, got in a car accident and needed a transfusion? Let's say they're rushed to the hospital and you give them blood from someone with A and B molecules. Well, what would happen is that this guy's antibodies against B would go and bind to the B molecules on the blood that he's just received, and then his body would start to destroy all of these cells that he just received. And that's bad because, first of all, it's a waste. You gave this guy blood and now he's just going to destroy it. But second of all, it's going to cause a huge amount of inflammation because this guy's body is going to suddenly see all these antigens that he thinks are really dangerous, and it's going to cause his whole immune system to rev up, and that'll actually be bad for him. So let's go through all the different possible transfusions between these different kinds of people. Let's go through them methodically by drawing a table. So on one side of the table we'll have the donors. So bear with me as I draw this table out. We'll have AB donor, A donor, type B donor. And do you know what we call this kind of blood? We can't call it type B or type A because that's these guys. So we actually call this O, type O. And then we also have the same guys as possible recipients. So we have type AB blood recipient, type A blood recipient, type B blood recipient, and type O blood recipient. And let's make this into a table. Okay, so here are our donors, blood donors, and here are our blood recipients. So what did we say before? We said that someone with type A blood cannot receive blood from someone with type AB blood. So that means that A recipient with AB donor is no good. Well, how about someone with AB blood? Can they receive blood from someone with AB blood? And the answer is yes, because the guy with AB blood has no antibodies against A or B, so he won't attack the AB blood that is given to him. So why don't you pause the video for a moment and try to fill in the rest of this table. Okay, so hopefully you've paused for a second and tried to fill in the rest of the table, and now we'll fill it in together. So someone with AB blood can receive blood from A, he can receive blood from B, and he can receive blood from O, because he has no antibodies to either A or B, so he won't react to any of these guys. Now likewise, someone with type A blood can of course receive from A, B can receive from B, O can receive from O, but B cannot receive from AB, nor can O, nor can B receive from A, nor can O receive from B, nor can A receive from B. But O can give to everyone. So something interesting you'll notice here is, as we just said, O can give to anyone because the O blood type has no A's or B's on it, so no one's going to react to it. So for that reason, we call O the universal donor. And the other interesting thing you'll notice is that AB can receive from everyone. So for that reason, we call him the universal recipient. And all these things, by the way, AB, A, B, O, these are blood types. So when someone asks you for your blood type, this is what they're referring to. And this is why it's really important to know your blood type if you're ever going to require a blood transfusion.